This puzzle's called, I guess, Untitled by Plica? Plica maybe? Yeah, that's an L, so I think it's Plica. I got it from the Sudoku Testing Submissions channel of the CTC Community Discord. Let's take a look at the rules. So we have killer Sudoku rules, so digits in cages add up to the number shown, so these three digits are going to be 15. These digits are going to add up to 15 also. These are going to be 16, these are going to be 13. It's pretty easy, and digits can't repeat generally in cages, but all of these cages are always in the same box, so that's never an issue. Okay, so then the next thing is arrow Sudoku. So we have kind of the head or the bulb of the arrow, which is the circle, and the digits along the tail or the arrow or the rest of it are added up and must add to this digit. So if these three digits are, let's say, 1, 2, and 4, then this would have to be a 7 because 1, 2, and 4 add up to 7. Yeah, I mean, it's just pretty, whoops, let's not leave the 7 there. I will get confused by that. It's pretty simple. Both, not necessarily simple as an easy, but both rule sets are simple because they lack complexity. It's just very straightforward. Digits add up to the number given, or digits add up to the number in the circle. Yeah, so if you want to give it a try yourself, I'll put a link down in the description. I do not know how hard it is, but we'll see. We'll see along the way, I suppose. Yeah, so let's get going. So the first thing to notice is that a lot of these are longer arrows. By longer, I mean 3 or more cells along the tail of the arrow, or I guess the arrow part of the arrow. So the minimum I could type into 3 digits like this is 1, 2, and 3, of course, and that adds up to 6. So if you have a 3-cell arrow like this, it must be the digit in the cell must be at least 6. So 6, 7, 8, or 9, and this one is like that, but also it has an extra cell after that, so that makes it a minimum of 7. If we did 1, 2, 3, and then a 1, this would be at least a 7. And this one has a minimum of 6, I think. So if we did 1, 2s kind of all the way down, that would be a 6 minimum once again. So I think there's a little bit more we could do. So with this longer one, and let's color that so I can kind of reference it more easily. So the orange arrow here, we know these have a minimum of 1, 2, 3. So the maximum we could put into this cell is a 3, because 1, 2, 3 plus 3 is 9, of course. So the maximum this could be is a 3, so that's a 1, 2, or a 3. But now we have a bunch of longer arrows kind of looking in at this 1, 2, 3. So, like for instance, here we couldn't make this a 6 now, because if we put a 1, 2, 3 here to make this 6, we now have 4 digits that are 1, 2, or 3. And that's not going to work, obviously, because you only get 3 digits that are 1, 2, or 3 in each box. So that can't be a 6. Same for this. We'll end up with 4 digits in the same row. Oops. Hit undo one too many times, so that one's not 6 either. And also, same here. This can't be a 6, because that would end up with this being a 1, 2... Sorry, that would end up with 1, 2, 3 here, which would clash with that. Okay. Let me just think a little bit. So this is, how do I want to do this? This is a minimum of 10, because if you have 4 digits in the same box, it would be, the minimum would be 1, 2, 3, 4. Or maybe it'd be better to do it this way. This is a minimum of 15. If we put in 1, 2, 3, 4, 5 in this row, this would be a minimum of 15. Then in this row, let's actually change these colors to show accurately what I'm saying. So orange is a minimum of 15 because we have 5 digits in the same row. So it could be 1, 2, 3, 4, 5. Then green is 4 digits, so minimum of 1, 2, 3, 4. And then we have blue, which is just a minimum of 1. So if we minimized blue, green, and orange, that would be 15, 25, 26. So that is incredibly large. 26 is, yeah, incredibly large. The only way to make 26 in 3 digits, since the digits can repeat luckily, is 998, I believe. Yeah, 998. Because 999 would be 27. So it's 998 or 99, what did I say, 998 or 999 are the only two options. So we can never have a 7. And in fact, this is going to be a 1 or a 2. Yeah, we have 1 digit of leeway. If we did absolute minimums all the way across, let's just type that out. Absolute minimums all the way across would be like this. And, but we do have 1 digit of leeway here. So this could be, let's say, a 2, and then minimums everywhere else. Or this could be a 1, and then we could have, you know, maybe bump the 4 up to a 5. Or we could have, we could be 1, 2, 3, 4, and a 1 up here in blue, and then pop a 6 into one of these. So how does that affect? Is there another? Is this also happening down here? A little bit, maybe? 10 plus 10. So let's look at this. This is 10. Red is minimum of 10 because, again, it's 4 digits. Yellow is also 4 digits, so minimum of 10. And pink, I guess, is just 2 digits, so minimum of 3. So the 3 lines down at the bottom, the 3 lines, arrows down here, add up to a minimum of 23, which is much more, so much less constrained, sorry. Especially given that we can repeat these two. So we can't rule out 6s, unfortunately. See if we can figure something out. I think maybe the top is where we need to look. I don't think having all these typed out is helpful at the moment. So we know at least two of these are 9. All 3 of them could be 9, though. Is there a reason why all 3 of them could not be 9? I don't see a reason why. Unfortunately, I do not see a reason why. Maybe... No, I was thinking maybe there's something vertical going on, but I don't think so, because once we start, like, doing vertical and horizontal, the summing up of stuff gets a little weird. So yeah, let's focus on the top up here. Let's get rid of these colors for a second. So this is either 1, 2, 3 or 1, 2, 4. Could it be a... Could this... Yeah, this could add up to 8, actually. And then have a 1 here. If this added to 8 with a 5 in it, that would mean all of these were 9, because we said this was 1, 2, 3, 4 at a minimum. So if this was 1, 3, 5, this would be a 1. Well, if this was a 1, this would have to be a 9 anyway, because the only way we could make anything would be 2, 3, 4, which adds up to 9. Yeah, this is 1, this would have to be 2, 3, 4 to make just any valid... No, that's the only valid answer there is. And again, I guess if this is a 1, this is going to be 9, this is going to be 9, this is going to be 9. All of these are going to be 9. Because all of these would have to be 2, 3, 4, because that'd be the only option left. Which would make this a 5. Because this would have to be 2, 3, 4. And this could be a 1. And then 1, 2, and then this would be 9 as well. Geez, everything would be 9s up here. If this is the one, everything is 9s. Except for this, down here, because this one literally couldn't be a 9. Because we see so many 9s. Oh, but this would be a 9, because it would see a 1. Does this break somehow? 9, 9. One of these would be a 9. We would end up in a 9 in here, which would break the puzzle, because you can't do a 13 cage. I don't know if that's where I'm supposed to look or not. That seems pretty wild to do that. Although it is, I mean, it's pretty direct. How, like, this 1 forces so much stuff. Yeah, you can't put a 9 in here because we've just said that this must be a 1 in order to get this arrow to work. But I think there's probably something better to look at, so removing 1 as an option probably isn't the best place to look. Well, okay, here's the thing. We know that there must be a 1 in here, because this adds up to a maximum of 8, and 8 in 3 digits must have a 1. So, and this, no, this could be 2, 3, 4, right? But if this is 2, 3, 4, if this is 9, it either has a 1 in it, or it's 2, 3, 4. Those are the only two. Those are the only options. The options for 9 in 3 cells are 1, 3, 6, 1, 2. Sorry, 1, 2, 6, 1, 3, 5, 2, 3, 4. It's really hard to say, just like strings of digits while you're typing different strings of digits. But yeah, these are the only options for 9 in 3 cells. So we're either going to have a 1, or it's going to be 2, 3, 4. And if it's 2, 3, 4, this is a 1, which means this can't be a 1. So, green, yeah, so neither of these could be a 1. So if this is an 8, blue must be 1. And if it's, oh, I'm dumb. I'm dumb. Let's just forget everything I said. Yes, it was mostly right, but it was also dumb. If this is a 1, this is 2, 3, 4, because that's the literally only option. I said that like 5 times. This is 2, 3, 4. We now have 2, 3, 4 in orange 4 times, and you can't do that. You can only have the digits once in a row. So all this crazy stuff I was doing was totally unneeded. You just have 2, 3, 4 times. What? So this just literally can't be a 1 like immediately. Which means this can't be 2, 3, 4, which means this always has a 1. And this is either 6 or 7, so this always has a 1 and a 2 in it. And this always has a 2 or a 3 in it. It can't have both, because that would break this, but it's either... Maybe I should just open up Notepad rather than typing in random cells. Let me just pop Notepad open on the screen. There we go. So 8 is either 1, 2, 5, 1, whoops, 1, 3, 4, 1, 2, 6, 1, 3, 5, 2, 3, 4. So no matter what, given that this has a 1, this is going to have a 2 or a 3, but not both. Which means this cannot be a 2 or a 3. Or a 1. So it's 4, 5, or 6. And this can't be a 1 or a 2. So this can't be a 6, actually. Because this is the minimum of a 3. So this can't be a 6. The 6 plus 3 would be 9, and then we would already need another digit up here. Now this is a 1 or a 2. Let's see, 1, 3, 5 would be 9, 1, 3, 4 would be 8, 2, 3, 4 would be 9. Yeah, it seems like it's reasonable. If this is... No, this can't be 2, 3, 4, because that would break this cell. So this can't be a 2. This must have a 1 in it, because it cannot be 2, 3, 4. So this is a 1. That means these two need to add to 7 or 8. Which means that this can't have... If we raise this up, that'll be 4 plus 4 or 4 plus 5, which 4 plus 4 you can't do because that would be repeated 4s. And 4, 5 would be 10 overall. So this has to be a 3. And then it's either 4 or 5 to equal 8 or 9. So now this can't have one, well, this is just a 2 now. But this can't be 1, 2, 3 because there's a 3 right there. So this must be 1, 2, 4, which makes this a 9. Now this can't have a 2 in it. So the options are 1, 3, 4 or 1, 3, 5. 1, 3, 4 or 1, 3, 5. And I guess we don't know. If this is a 5, yeah, we're at minimum. We're at minimum here. So one of these is an 8, one of these is a 9. If this is a 5, this is a 9, and this is going to be 1, 3, 4, which makes this an 8. Or we could reverse that, and this is a 4, this is an 8. This doesn't have a 4, and then this is bumped up to a 9. Okay, that's fine. I think that's all we can do up top for the moment. I guess this can't be a 1 or a 4. That's fine with me. Yeah, okay. Sorry if you can hear my chair. Every time I move, it's like it's crying out for help, I guess. 6, 7, 8, 9 left in the row. I guess that's not super helpful. Okay. So let's look at this one here. This can't be a 7. 7 requires 1, 2, 4, and then that would be... I guess I could type that in as well. 7 requires 1, 2, 4, and 6 requires 1, 2, 3. So because of this 2 here, we can't do 7 as 1, 2, 4. So this can't be 7. And this must have a 1 as well. Because it can't be the 2, 3, 4 option down here that doesn't need a 1. So it's either 1, 3, 4 or 1, 3, 5. And it must have a 1 and a 3. I believe that's right. It has a 1, does not have a 2. 1, 3, 4, 1, 3, 5, yeah. Just gonna double check that really quickly. Okay, so what is this? What can this cell be? It's a minimum of a 4. And this cell is a minimum of a 2. Which matches up, actually, because we said this has a minimum of 3. 4 plus 2 plus 3 is 6. Sorry, 4 plus 2 is 6, plus 3 is 9. So this can't be a 1. And we've minimized this as a 9. So this can't be a 9. Yeah, that's fine. So this can't be a 7, actually, because, again, 7 needs 1, 2, 4, and we put a 4 in the row already. But it will have a 1 in it. It's either 1, 2, 3 for 6, or 1, 2, 5 for 8. So this has a 1 and a 2 in it. Okay, I think that's all right. We have a 2 in one of these 2 cells. A 1 in the box over here. Maybe we need to look up options for 13. Let's see, this has... Oh, there's a 4 right here now. This can't have a 4. That's the thing that I should have noticed right away. Whoops. Keep pressing the wrong button. So that's 1, 3, 5, making that a 9. So these are not 9s. So one of these is a 9. Okay, I thought that would do more than that, but it didn't actually. It did very little. I thought that was going to cascade up to the colored cells up here and, like, tell us stuff. It told us nothing. Okay, so 3 is along here. Could we have 1 and 3 both in here? Yes, that would be 1, 3, and then a 9. That would be just fine. So we can't rule 3 out of there. What about along here? Let's look at this one. This one can't be 6 or 7 because, again, it would have to have a 2 in it. So, whoops, what did I just do? I don't know where I just typed. But I just typed 6 and 7, and it didn't remove the options here or do anything to Notepad. So I'm a little worried where I might have put that 6 and 7. So this is an 8 or a 9, and it doesn't have a 2. So we're going back to our classic 1, 3, 4, 1, 3, 5, and it must have a 1 and a 3 in it. Right? I've done this like 3 times this puzzle, and every time I have to check. Yes, 1, 1, 3, 4, 1, 3, 5. This is not 1 or 3. This is a 1. This is a 3. Now this can't have a 3, so this is an 8, which makes this a 9. And now we're getting the kind of cascading effect that we wanted earlier. So this can't have a 4, this is just 1, 3, 5, making this a 4, making this an 8, making that a 9. Puts a 9 over here. Oh, and actually must just be in the middle there. I think we're good on that. I'm just trying to look for basic Sudoku before I move on to, like, this box or anything else. I think we're good. This can't be a 1, because there has to be a 1 in here. We don't know which one it is yet, though, I don't think. Okay, so let's... These two digits need to add up to 12. And they can't be 3, 9, and they can't be 4, 8, so it must be 5, 7. That doesn't actually help. Okay, that's great. These digits in this column are 6, 7, 9. Okay, that does help. This must be the 7 because we can't put another 7 down here in the box. And then this must be an 8. Oh, that is helpful. So now this is a 9. This needs 1, 3, 5. This must be the 7. This must be the 5. And this can't have a 5, so this is the 2. I don't think we can do much more with that. Okay, so this can't be an 8 or a 7, so this is a 6. And this is the 5 for the row. And what's left is an 8 and a 6. And this is the 8, this is the 6 because of that 8. Okay. Yeah, it helps when you're actually, like... I was doing such stupid stuff, and I was just thinking back to the beginning, how dumb I was being. Okay. Let's see. Let's look at this column here. We need a 2, a 4, and an 8. So this is just a 4, because it can't be a 2 or an 8. And we need a 7 or a 6, which we don't know about yet. 9 is in one of these two, which matches up with the last 2-digit 9s, or the last 2 copies of 9, I mean. This needs to add to, this pair needs to add to 7, and it can't be 1, 6, so it's 2, 5, or 3, 4. Is there a problem with either of those? I don't think so. Whatever digit is in here is going to be in here. Oh, not 2, 3, it's 2, 4. Okay, yeah, that's the easier way to look at it. So where can 2 go in box 1? This 2 is looking up, and 2 is going to be forced into this box. So this is a 2, 5 pair. Yeah, that's the easiest way to do it. And then this can't be a 1. We need a 7 and a 6. There's a 6 looking down, so this is a 7, this is a 6. Oh no, not quite. I thought that was a pair, but it is not. The pairs are vertical over here. Okay, let's look at these. This is a 3, a 6, and a 7. This can't be a 6. Okay. If this was a 9, these would have to add to 7, which would have to be 3, 4. Is that a problem? I don't think so. So what are these digits? So this must have a 6, that's good, and an 8, and a 4. So we have 2 8s, so this must be the 8. Then we have a 6 looking down, so this is a 6, this is a 4. So this 6 is gonna figure out the 9s, actually, which is very helpful. Because we literally just said this has to be 9, 3, 4 if this is a 9. Then we can sort those out as well. So this 4 is looking up, so this is a 2. We need an 8 as the last digit for the column. Okay. Oh, this is just a freebie. This is just the last 8 in the row, or the only 8 in the row. Then we need a 2 and a 7. Nope, can't quite figure that out. Okay. Maybe it's this 15 cage. Let's see, is there something else I can do that I noticed right offhand? Oh, there is something small. So where can 6 and 7 go in here? One of them is already there, but we can't put the other one here, so this is the other of 6 or 7. So this is going to be 3 or 5. Yeah, that didn't help really at all, but might as well fill it in. Okay, let's look at this 15. And just to be thorough, let's look up all the options for 15 in 3 cells. Unfortunately, there's quite a bit of them. Let's do... Yeah, there we go. So this is, yeah, 15. Oh, actually, now that I think we've finished all the arrows, so we can just delete, whoops, we can just delete all this stuff up here. So this is 15. So we can't have a 9 and we can't have an 8. Apologies, it seems like when I was recording it, I accidentally hit my mute button while I was messing with these triples here. I don't know exactly how I did that, but I didn't notice it until I was already done and noticed that there was a huge muted segment at the very end. So let me just go over what we're doing. So I just realized that 8 and 9 can't be in the 15 cage, so we'll remove those options from the list. Also, we can't have a 6 and a 7. So, because if this was 2, 6, 7, then this cell over here would have no digit that could fill it. And same with 3, 5, 7. 3, 5, 7 wouldn't work either, so therefore it must be 4, 5, 6. And then it's going to be pretty easy deductions from here. Just basic Sudoku, removing options and around. That was the last big deduction of the puzzle. Fours rule, or force 4 over to the side, and so on. Overall, this puzzle is probably like a 2, maybe a 2.5 out of 5 difficulty. I did make it much harder on myself there at the beginning, thinking about the orange in very wrong way and just missing the obvious that if I made this a 1, then the puzzle breaks. So probably closer to 2 out of 5 difficulty, but a very fun puzzle. I really like the puzzles with more simple rule sets. Like, simple as in not, again, not easy puzzles necessarily, but not complex rule sets. Just killer cages, arrows, that's it. That's all you have to think about. So yeah, I just finished it up, and you can obviously see right there. Um, and yeah, that was a very fun puzzle. Thank you very much, Plica or Plica. I'm not sure exactly how to pronounce it. Oh, this is just me saying the same thing, I think. That I made it much harder on myself than I needed to. And thank you all for watching, and apologies for accidentally muting partway through. Luckily, it was at the very end, so I basically knew what I had to say in my dubbing over bit. And thank you all for watching, and I'll see you next time.